رب اشرح لي صدري ويسر لي أمري واحلل عقدة من لساني يفقه قولي.
Bismillahirrahmanirrahim. Assalamu alaikum, dear students. I hope all of you are fine and doing well. स्टार्ट करते हैं अच्छी बात से। और आज आप लोगों के साथ कुरान पाक की एक आयत शेयर करना चाहूँगी जिसका तर्जुमा कुछ इस तरह से है। ज़्यादती की चाहत ने तुम्हें गाफिल कर दिया, यहाँ तक कि तुम कब्रिस्तान जा पहुँचे। तो प्यारे बच्चों, हमें कोशिश करनी चाहिए कि हम अपनी डेली रूटीन में ऐसा टाइम निकाल सकें कि हम डेली बेसिस पे जो है वो कुरान पाक की तिलावत करें। 5 वक्त की नमाजें जो है उनको हम वक्त पर पढ़ें और जितना मुमकिन हो सके हम अपने आप को बुरे कामों से बचाए रखें और अच्छे काम करें जिससे दूसरों को भी मदद मिले, उनका भी फ़ायदा हो और ऑटोमेटिकली हमारा भी फ़ायदा साथ में होता रहता है। Dear students, in the today's video, we are going to solve assignment 2.1 from the unit 2, that is vectors and equilibrium. And also we will solve the activity given on the page number 42. Dear students, assignment 2.1 is an airplane is moving at 120 meters per second at an angle of 10 degrees with x-axis through a 30 meters per second crosswind, blowing at an angle of 260 degrees with x-axis. Determine the resultant velocity of the airplane. Dear students, we can solve this question either by the head-to-tail rule, and also we can solve this question by the rectangular component method. While the rectangular component method is more accurate as compared to the head-to-tail rule, but I will show you to solve this question by these both methods. So first of all, we will solve this question by the head-to-tail rule. First of all, we will write down the data that is given in the question. So the things that are given in the question are, first of all, the airplane is moving at the velocity of 120 meters per second at an angle of 10 degrees with x-axis. So the velocity v1 is equal to 120 meters per second with an angle of theta 1 that equals to 10 degrees with x-axis. And there is a crosswind which moves with the velocity of 30 meters per second, and it is making an angle of 260 degrees with the positive x-axis. So these are the terms that are given in the question, and we have to find out the resultant velocity of the airplane along with its direction. So by solving this question by the head-to-tail rule, the very first step is to select the scale according to which we will draw these given vectors. And the choice of scale is totally up to us. So now let us consider that the velocity of 10 meters per second is equal to 1 centimeter. So we have selected this scale according to our choice. You can also select 20 meters per second equal to 1 centimeter. You can even also select 30 meters per second equal to 1 centimeter. So dear students, स्केल की जो चॉइस है ये टोटली आपके ऊपर डिपेंड करती है कि आप किस वैल्यू तक जो है उस स्केल को स्मॉल रखते हो या आप उसको बिग बना देते हो. उसे टोटली आपके ऊपर डिपेंड करता है. सो नाउ we have to convert the given velocities in according to the given scale. Then the velocity of 120 meters per second will be equal to 12 centimeter, while the velocity of 30 meters per second will be equal to 3 centimeter. And now we will draw these vectors on the coordinate axis. So now let us first draw the coordinate axis, the vertical axis and the horizontal axis, y-axis and x-axis. So vertical with the positive and the negative y, and horizontal axis with the positive x and the negative x axis. So now we will draw the given vectors by the head to tail rule. So starting from any one of the vector from the origin, आप v1 को भी origin से draw कर सकते हो और आपकी choice है कि आप v2 को origin से draw करो. So आप v1 या v2 किसी भी एक vector को origin से जो है वो start कर सकते हो with the particular direction. Yes, students. Now let us first draw the vector v1 having the magnitude of 120 meters per second, which is equal to 12 centimeter, and it is going to make an angle of 10 degree with the positive x-axis. So first of all, we will draw the vector v1 starting from the origin, making an angle of 10 degree with the x-axis. So I am just going to draw the arbitrary magnitude and the direction. It will not as much accurate as if you draw it on the piece of a paper while using the scale and the protector. So this is the vector v1 with the magnitude and the direction. Now to draw the vector v2, we have to draw it from the head of the first vector, that is the v1. So now let us shift this angle, these coordinates onto the head of the first vector, that is v1. So now from the head of the first vector, we will draw the tail of the second vector, that is equal to the magnitude of the 3 centimeter, and it is going to make an angle of 260 degree from the positive x-axis. So now we will draw the velocity vector v2, making an angle of 260 degree, and the magnitude is 3 centimeter. So this is how we can draw the diagram of the velocities for the vector addition. Now what we will have to do, we have to draw the resultant velocity for these two vectors, and we have to draw the resultant from the origin and ending up to the head of the second vector. So join the tail of the first vector with the head of the second vector. So it will somehow look like this. So the yellow vector is the resultant velocity vector, while its direction with the x-axis is equal to theta. So v is the magnitude while theta is its direction. So you can simply find out its direction by using the protector. So its direction will be actually measured from the positive x-axis in the anti-clockwise direction. So this will be the angle for this resultant vector in actual. And you can find out the magnitude of this velocity vector simply by using the scale. So whatever the length you will get from measuring by this vector by the scale, you have to multiply that measurement with the selected scale, that is 10 meters per second, so that you convert the length from centimeter into the velocity, that is in meters per second. तो जो भी आपकी वैल्यू आएगी इस गिवन वेक्टर की, उसको आपने 10 मीटर्स पर सेकेंड से मल्टीप्लाई कर देना है ताकि आप एक्चुअल वेलोसिटी वेक्टर की जो वैल्यू है उसको आप कैलकुलेट कर सको। क्योंकि ये वेक्टर्स मैंने जस्ट रफ ड्रॉ किए हैं आप लोगों को एक आइडिया देने के लिए कि किस तरह से हम हेड टू टेल रूल के अकॉर्डिंग इस क्वेश्चन को सॉल्व कर सकते हैं, तो इस वजह से मैं यहाँ पे इसका आंसर जो है वो मेंशन नहीं कर रही। लेकिन जब हम इस क्वेश्चन को रेक्टेंगुलर कंपोनेंट मेथड से सॉल्व करेंगे तो वहाँ पे आप जो है एक्यूरेटली आंसर्स को जो है वो कैलकुलेट कर सकते हो। सो इस तरह से कुछ डायग्राम इसकी जो है वो बनेगी और इस तरह से इस मेथड से जो है वो आप रिजल्टेंट वेलोसिटी जो है वो एयरप्लेन की कैलकुलेट कर सकते हो, उसका मैग्नीट्यूड भी और उसकी डायरेक्शन भी। लेकिन ये मेथड इतना एक्यूरेट नहीं है जितना कि रेक्टेंगुलर कंपोनेंट मेथड एक्यूरेट है, बिकॉज इन दैट वी विल यूज द मैथमेटिकल इक्वेशन। लेकिन हमें दोनों मेथड से इन क्वेश्चंस को सॉल्व करना आना चाहिए, बिकॉज पेपर में अगर मेंशन कर दिया जाए कि आपने इस क्वेश्चन को हेड टू टेल रूल से ही सॉल्व करना है, देन यू हैव नो चॉइस। So if in the paper they mention to solve this question either by the head to tail rule or the rectangular component method, then you have to follow that instruction. Otherwise, the choice is totally yours. So this is how we can solve this question by the head to tail rule. Dear students, now we will solve this question by the rectangular component method. So to solve this question by the rectangular component method, we first have to resolve the given vectors into their rectangular components. So we are given the two vectors, the vector v1 equal to 120 meters per second while making an angle of 10 degrees with the x-axis, while the velocity vector v2 is equal to 30 meters per second while making an angle of 260 degrees. So the very first step is to resolve these vectors into their x and y components. So first of all, we will solve them for the x component. v1x will be equal to v1 cos of theta 1, while v2x will be equal to v2 cos of theta 2. So dear students, now substitute the values and try to get the answer. 120 into the cos of 10 is equal to 118.17, while v2 cos of theta 2 is 30 cos of 260 degree. So 30 cos of 260 degree is equal to minus 5.21. So from this, the Vx component will be equal to V1x plus V2x, while V1x is 118.17 and V2x is minus 5.21. So 118.17 minus 5.21 is equal to 112.96 meters per second. So the x component of the velocity comes out to be 112.96 meters per second. Now we will solve this for the vertical component. So to solve this for the vertical component, v1y will be equals to v1 sine of theta 1, while v2y will be equals to v2 sine of theta 2. So this is equal to 120 sine of 10 degree, and this is equal to 30 sine of 260 degree. Now let us calculate. 120 sine of 10 is equal to 20.84, while 30 sine of 260 is equal to minus 29.54. So Vy will be equal to V1y plus V2y. It means we have to add their values 20.84 minus 29.54. So this will come out to be 20.84 minus 29.54, and we get Vy as minus 8.7 meters per second. So the x component of this resultant velocity vector is positive, while the y resultant is negative, and it comes out to be 8.7 meters per second. Now we have to find out the velocity of the resultant vector by using the formula that equals to v is equals to vx squared plus vy squared. This is the formula which we can get from the Pythagoras theorem if we add the vertical and horizontal component. So by substituting the values into this formula, which is 112.96 squared plus minus 8.7 square and the square root. So the velocity vector magnitude will come out to be 113.3 meters per second. So the magnitude of the resultant velocity is equal to 113.3 meters per second. And to find out the direction of the resultant velocity vector, we will use the tangent ratio formula. Theta is equals to tangent inverse Vy divided by Vx. So the vertical component of the velocity is minus 8.7, while x component is 112.96. So this come out to be, theta will be equal to 4.4 degree with the x-axis. From this angle is actually the reference angle, which is measured in this direction. So angle theta is measured from the x-axis in the clockwise direction. Since these resultant vectors are in the fourth quadrant, then what we have to do to find out the angle theta, we have to subtract 4.4 degree from 360 degree. So 360 minus 4.4 is 355.6 degree. So the actual direction of the resultant velocity vector is 355.6 degree with positive x-axis. So this is how we can solve the same question with the rectangular component method. And also you can solve this question from the head to tail rule. From both of the two methods, you will get the similar result, but the rectangular component method is more accurate. Now, dear students, let us solve this activity that is given in your book on the page number 42. The activity is try drawing these vectors in different orders and confirm that the magnitude and the direction of the resultant R of the vectors is same. Now, dear students, the very first step is to draw the coordinate axis, the vertical and the horizontal axis, so that on these axes we will draw these given vectors. And again, I will draw these vectors with the arbitrary magnitude and the arbitrary direction, since I am not using any kind of scale or the protractor. But while you will solve this activity, you have to draw these vectors according to the given directions and of the particular magnitude. So in this activity, what we have to show that the resultant vector is independent of the vectors addition. Like if you add A, B, C, D, you will get the same resultant. Even if you add B, C, B, A, so you will get the same result. Hence, the vector addition is commutative. So you have to prove this sentence. So now let us draw the vectors starting from the vector D. तो सबसे पहले हम वेक्टर D को ड्रॉ कर लेते हैं from the origin, and then we will add vector A in the vector D. Then we will add vector B, then vector C, and hence we will draw the resultant from the origin to the head of the last vector. So either you draw A, B, C, D or D, A, B, C. So for both the two methods, we are getting the same resultant in the same direction and the same magnitude. Now let us try something different. Instead of drawing the vector D first, now let us draw the vector A first. No, sorry, A is already drawn. So let us try with the vector B. So from the origin, we will draw the vector B in the same direction. Then the vector C, then the vector D, and at the end, vector A. And then again, we will join the tail of the first vector with the head of the first vector to get the resultant. So yes, we are again getting the same result. And now in this case, the numbering in which we have added the vector is B, C, D, A. So whatever the sequence of the addition of the vector is, you will get the same resultant. So the vector addition is commutative. It does not depend either you are going to add A into B or B into A, you will get the same result. So hence it is proved that the vector addition is commutative. This is the end of today's assignment. Thank you so much. I hope all of you have enjoyed today's lecture. For any kind of queries, you can write your question in the comment section. See you in the next video with a new topic. Till then, take care and Allah Hafiz. Dear friends, if you like my videos, kindly subscribe to my channel and don't forget to click the bell icon for the latest updates. Thank you so much.